Ampersand have permission for a sea wall to be built at Carlyon Bay. In the process of developing the detailed proposals, Ampersand went to the world's leading coastal engineers. The planning process involved consultation with the Environment Agency, statutory and non-statutory consultees. The existing 1990 planning permission, which was renewed in 1996, includes in its design a vertical concrete sea wall, together with exposed rock armour protection. The Environment Agency now recommend higher standards of protection to improve safety and limit the risk of damage to property. This includes the latest requirements with respect to sea level rise. Ampersand want to ensure the public has access to the beach. Should the new proposed sea wall be consented, then this issue will be guaranteed through the Section 106 agreement between Restormal and the applicant. Ampersand want to deliver an improved beach amenity, better than that provided by the existing planning permission. The new proposed design increases the beach area by some 6 acres, together with burying the unsightly and potentially dangerous rock armour. Similarly, the design will improve access for all to the beach to reflect current access requirements for all groups of people, including disabled, families and the elderly. The existing planning permission had no allowances for the management of the sea defences. This application addresses this issue through a beach management plan, which has been agreed in principle with the Environment Agency and will be enshrined in a Section 106 agreement for the maintenance of the beach and the sea defences. The new proposals provide for the implementation of an ecological management plan, which is not part of the existing planning consent. Included within this plan will be the day-to-day management of the beach, which will include cleaning and removal of litter. A rigorous design process led by HR Wallingford assessed the design using the following. Computer beach modelling was used to assess long-term stability of the beach, the natural beach cycles, its response to extreme storm conditions, and how the beach would recover naturally after such conditions. Two-dimensional physical modelling was used by creating a slice of the beach, sea wall and promenade constructed in a 50-metre-long wave tank to examine the effectiveness of the sea wall and beach under extreme storm conditions, to optimise the shape of the sea wall, to limit any overtopping and consider the effectiveness of the beach. A three-dimensional physical model was then constructed in a large wave tank measuring 20 metres by 20 metres. This model was used to assess the three-dimensional characteristics of the scheme and how it would respond to extreme wave conditions, including the 1-in-200-year storm. These comprehensive studies have resulted in the experts recommending that the profile of the wall is improved by changing from a vertical sea wall to a curved profile. The exposed rock armour is replaced by a much more substantial but concealed rock armour toe. This is then covered with imported sand to match the profile of the existing beach and to ensure that the beach can respond to storm conditions. This beach recharge will widen the beach by an average 16 metres, reduce the apparent height of the new sea wall and improve the beach amenity. This new design is a combination of a wider beach, concealed rock armour and profiled sea walls, which act together to provide an improved sea defence. It is essential that the development does not adversely affect the coastline to the east, including Parr, or the coastline to the west, including Charlestown. Crinis, Shorthorn and Polgaver together form one large pocket beach. This beach is largely retained within the bay. However, like all beaches, there are significant changes of cross-section, profile and plan shape, which need to be accommodated in the design. When easterly waves dominate, the beach responds by rotating slightly. Conversely, when westerly waves dominate, the beach responds by rotating the other way. Long-period simulations using real-time data were run in a computational model called Beach Plan to examine the responses to change. The modelling indicates